All right, let's start some trig. Whoop whoop. I know the time you've all been waiting for. So, when we start our trig here, we're going to start at the basics. So, we're starting off nice and easy with angles, arcs, and their measures. So we're just want to kind of set the stage, get things set up for us, and then we can move forward with our trig. All right, so there's a couple of things that we want to talk about. If I have an angle, when you have an angle, you are always going to start, whenever you do your measurement, on this initial side, it's called. And then you're going to go up here to the terminal side. So just getting some vocab in there. So on your initial side, then whenever you're looking at whatever your angle measurement is, you're coming up through here, and then that's going to be your angle measurement to that terminal side. So that's just notation that we're going to be using. Also, if I have an angle measurement, well, let's try this again. Pardon me. If I have an angle, let's say I'm going from here into here. If I have my initial side and I go through here in the counterclockwise direction, that is going to be a positive angle measurement. All right? If you're going counterclockwise, you still have your initial side. Here's where you start, and you're coming all the way around to your terminal side. That's counterclockwise. If I have an angle, it may look the same, but if I'm going clockwise direction, that's going to give me a negative angle measurement. All right, if it's going in the clockwise direction. When we talk about the unit circle in this very next section, that's going to make a huge impact because you're starting here, and if you go around in the counterclockwise direction, then everything is going to be a positive angle measurement. If you start here at your initial side and you go down and around, or however you get there, going down that clockwise direction, that's going to give you a negative angle. All right? So just notation. We're setting stuff up for our notation. Something else that I think is going to be helpful is we are talking about different types of angles. So if I have, such as for example 1, if I have this setup, and there's a box in the corner. Do you know what that box means? Right angle. Good. So I know that this is going to be a right angle. With this right angle, what does a right angle measure up to be? 90 degrees. Okay. So what if I split this up and I'm saying that this angle measurement is going to be 3x degrees, and this angle measurement up here is going to be 6x degrees, and we want to find x. So what do? Yes, if the two of them together give you that right angle, then you're going to take 6x plus 3x is equal to 90. So 9x equals 90, so x is equal to 10. So we figure that out. Pardon me. When you have two angles that add up to give you 90 degrees, they have a special name. Do you remember what those are called? Now, this is thinking way back to your geometry days. Complementary. Complementary angles are angles that add up to 90 degrees. All right? Okay. Now, what if I have this little situation? If I have, it's called a straight angle, right? What is the degree here of my straight angle? 180, good. So what if I have this one broken up here to say that this side is 6x degrees and this side is 4x degrees? Well, what do you do with that? Yeah, same thing. 4x plus 6x is equal to 180. So, oopsie daisy. My head goes faster than my hand there. 10x is equal to 180, so x is equal to 18. All right, so super easy stuff. Basically, this is just, here's a vocabulary lesson, right? And if I have two angles, or just however many angles that add up to 180 degrees, those are called supplementary angles. They add up to 180 degrees. So you have your complementary angles and your supplementary angles. Now here's a mnemonic device if this is brand new information for you. Here's a mnemonic device that I've always used. The CO in front of the complementary angles. So CO there for corner. That's what I think of. So complementary angles, that CO that it starts with is a corner, and a 90-degree angle makes up a corner. The S over here for supplementary, S for straight. And we know a straight angle is at 180 degrees. All right? All right. So getting some basics down, figuring this stuff out. Something else that I want to share with you, and I didn't make this in advance, so you're just going to have to bear with me while I take this picture here. And we do it like what it would be, kind of like what we were doing in class then, right? So in our book, we have this super cool chart right here. And I'm going to bring it down so that you can see this. Typically, when you get an angle measurement, a lot of times angle measurements are labeled in terms of Greek letters. Often, that's an O. Often, angle measures are denoted by Greek letters. The most common one is theta, right? You see this all the time, theta here. So this column on the left is capital letters. The column on the right are lowercase letters. I just think this is nice because we set this up so it works pretty good. Alpha and beta are used pretty often too, that we have it, but this is just nice, really, honestly, in order to pull this off. And so then you can get it. In statistics, sigma is used quite a bit because it stands for standard deviation. Mu stands for the mean. I mean, Greek letters are used often, right? Often. We're going to use some of these, like here shortly, omega, etc., in order to do some angle measurements and some formulas that we're going to be working at. Theta is our most common one that we're going to be using, however. So the angle measurement goes with that. But this is just nice, right? Just to have this extra little reference guide, if you will, in order to be able to pull this off. Okay. So the next thing that I want to talk about is when we have angle measurements, we are actually not going to use it a whole lot with what we do. We're going to use it some, but not a whole lot with what we do. I'm going to reach over here and grab my calculator because I'm going to show this in your calculator too. But we can also look at angles in terms of degrees, minutes, and seconds. So your angle can be broken up into degrees, which is the degree mark, minutes, which is a single little, I don't know, thing up there, and then seconds. More like a quotation mark then at that point. So an apostrophe is what I was trying to think of and I couldn't think of. So degree, or the minutes are just 1, the seconds are 2. Kind of like if you're talking about feet and inches, the same concept, right? Okay, except degrees, minutes, and seconds are what we're looking at. 1 minute is 1/60th of a degree. So it's still in the terms of that minutes and seconds timeline. So 1 minute is equal to 1/60th of a degree, or 60 minutes is equal to 1 degree, right? That same concept. The same thing with a second. So this is minute. Same concept with a second is if you have 1 second, that's equal to 1/60th of a minute, right, that you're looking at. Or 60 seconds is equal to 1 minute, right? And then it just goes from there. So you could write, for example, 12 degrees, 42 minutes, and 38 seconds, right? So that's just degree, then you break it into minute, then you break it into second after that. So that's another way to write it. Also, you can write this in terms of decimals, which is typically how those are written. So you're converting between the decimal degrees and degrees, minutes, and seconds. We're not going to do this by hand, people. There are reasons for calculators, and we are going to use it. All right? I don't expect you to be able to pull this off. It's just fractional conversions, and I get that. I totally get that. However, we're just going to do it on our calculator. So if I have example 3A, I'm going to take 74 degrees, 8 minutes, and 14 seconds, and I'm going to change this to convert to decimal degree, and then round to, what's this say, nearest thousandth. Okay, we're just literally going to use your calculator for this. Your calculator should, if you do the calculator, which I'm getting ready to show you that we have for this class, right? The one that I use all the time that we've got here. If you have a different calculator, then all you need to do is YouTube it or come up with something. A lot of Texas Instruments are very similar. Sometimes for the second key, they have the symbols. If you have a graphing calculator, you also have this math button. Under my math button, I'm going to arrow over to DMS, standing for degrees, minutes, seconds. And then that's where it's going to pull that out for you. All right? Okay, so I'm doing 74. Wait, where'd it go? 74 degrees. So math, degrees. So I have my degree first, so it's 74 degrees. And then I have, 8. And then I have to hit math. Go down to the minutes, select that, and then I have 14, go back, over, and then I have, oh shoot, dang, I hit the wrong thing. I had to arrow down. Let me try it again. Seconds. All right, and so then I hit enter after that, and then it puts it into degree mode because I am in degree mode. You see that up there, DEG, so I'm in degree mode. So you can always look at your mode. Make sure your degree, that is radian mode, we'll talk about later, but I'm in degree mode. That's where I need to be. So let me go up and then just hit enter again just so we make sure that we have that. Okay, so 74.137 because we said we're rounding to the thousandth. All right. Okay, so we have 74.137 degrees is where we have that. All right, then I'm going to take, if you can go that direction, you can also go back and forth from degrees, minutes, and seconds, and then take it back, right? Pardon me. So, for example, 3B, I have 34.817 degrees, and I want to convert to degrees, minutes, and seconds. So you literally just plug that into your calculator. Let me show you. So in your calculator, back to that same thing. Wait, I already forgot it. 34.817. All right, I'm going to go back into math, come over to my degrees, minutes, seconds, and I'm just going to keep on, that's radians, but I'm going to convert to degrees, minutes, seconds. So I'm converting that to degrees, minutes, seconds, and it literally does it for you. And that's how we're going to use this. So this will be 34 degrees, 49 minutes, and 1.2 seconds. If your calculator does this differently, get on YouTube and figure it out. Send me an email. I can help you, possibly. But most likely what I'm going to do is just